Hello all, good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Differential Equations and Transforms, and now we are on to the topic Laplace Transforms. In the previous videos, we have seen the initial value theorem and the final value theorem and also its verification process. This is a continuation of the previous video as well. Now, we are just verifying the final value theorem for the given function f of t is equal to 1 plus e power minus t into sin t plus cos t. Wherein we have just found that f of t and f dash of t are existing and L of f of t are also existing. Since we have the values for all of the terms in the f of t here, L of 1 is 1 by s, L of e power minus t into sin t is 1 by s plus 1 the whole square plus 1 plus L of e power minus t into cos t is s plus 1 divided by s plus 1 the whole square plus 1. These are all the formula of Laplace transformation. So that what we can say, L of f of t is equal to f of s is also existing. Now we are done with the conditions of final value theorem. What are these? F of t should exist, f dash of t should also exist, and L of f of t should be equal to f of s. Now, next thing is we have to verify the final value theorem. As we have discussed earlier, if it is a final value theorem, it should start with infinity and end at 0. In the LHS we have t and in the RHS we have s. So what is the LHS here? Limit t tends to infinity f of s. That is what we have taken up here. What is our LHS? It is limit t tends to infinity f of t. What is it? L of limit t tends to infinity f of t. What do you mean by this f of t here? We will just replace this f of t with a given function which is 1 plus e power minus t into sin t plus cos t. So we have just replaced this function 1 plus e power minus t into sin t plus cos t. So now what we will do on applying the limit, we will just replace this t with infinity. This 1 will become 1 only plus e power, this t will become infinity. E power minus infinity, we knew it is always equal to 0. So we need not worry about sin infinity plus cos infinity. Anything into 0 will become 0. Therefore, the value for this LHS as 1 plus 0 which is equal to 1. I will repeat it again. Here we have 1 plus e power minus t into sin t plus cos t. On substituting this infinity inside the brackets, we have 1 plus e power minus infinity into sin infinity plus cos infinity. Since we knew that e power minus infinity is 0 and we need not worry about sin infinity and cos infinity, therefore we have the second term as 0 and therefore the final value becomes 1. So what is our LHS? In the final value theorem, it is limit t tends to infinity, f of t is equal to 1. Now we are going to proceed with the RHS. What is our RHS then? It is limit s tends to 0, s into f of s. It is limit s tends to 0, s into f of s. We will have to just replace this f of s function here since we have found it already. So limit s tends to 0, s into, what is the first term in f of s? It is 1 by s plus 1 by s plus 1 the whole square plus 1 plus 1 by s plus 1 the whole square plus 1 plus the third term is s plus 1 into s plus 1 the whole square plus 1. S plus 1 divided by s plus 1 the whole square plus 1. So now what we have done here is we have taken this s inside the brackets to all of the terms here. So on bringing this s to 1 by s, we will have s by s, therefore it will become 1. Next term is 1 by s plus 1 the whole square plus 1, which is on bringing this s inside, you will have s on the numerator. So s by s plus 1 the whole square plus 1 plus this s will come here on the numerator, therefore s into s plus 1 divided by s plus 1 the whole square plus 1. So this is what we have, 1 plus s by s plus 1 the whole square plus 1 plus s into s plus 1 divided by s plus 1 the whole square plus 1. Therefore, on applying this limit s tends to 0 here, this will become 0, this will become 0, this and this will become 0, this will become 0. So the final term will vanish and this term will also vanish. The remaining term is 1 rho. So what has been now our limit? Limit s tends to 0, s into f of s is equal to 1. So from the first equation, LHS is equal to 1 and from the second equation, RHS is also equal to 1. Therefore, what have we got? The final value theorem is verified. This is how we verify the initial value theorem and final value theorem using Laplace transformations. Thank you.